Hi, my name is Todd Eckenstam, and I'm here with Ravi Hari. We will be discussing how to use GitOps to manage the lifecycle of cloud resources with Argo CD. First, I'd like to go over the high-level agenda of what we'll cover in this talk. We will briefly explain what GitOps is, some of its benefits, and why it's a good fit to be used with Kubernetes. We'll discuss the controller pattern and introduce some of the open source controllers that can be used to manage cloud resources. You'll also learn how Argo CD can be used to deploy cloud resources using those controllers. Next, we'll walk through how a custom tool in Argo CD can be used as an alternative to Kustomize or Helm to build a custom project format. Last, we'll wrap up the talk with an end-to-end demonstration of deploying cloud resources using Argo CD, as well as a discussion of our experience using GitOps add into it. If you signed up for this session, you may already be familiar with what GitOps is. But for those of you who aren't, GitOps is a process that uses a Git repository to store the desired state of an operational environment and a GitOps operator to perform the operations needed to make the actual operational state match the desired state. It's really a mechanism for doing DevOps. Instead of making changes directly to the system using a UI or a CLI, changes are made to those configuration files representing the desired state in Git. The GitOps process would start with someone on the team creating a branch and submitting a pull request containing some changes to the desired state of the infrastructure. Those changes can then be reviewed and approved using standard revision control processes. Once changes have been approved and merged to the main branch, a GitOps operator, such as Argo CD, is responsible for changing the system's current state into the desired state based on the configuration stored in Git. In an ideal implementation of GitOps, manual changes to the system are not permitted, and all changes to the configuration must be made through files stored in Git. GitOps provides many benefits to developers since it allows them to treat the configuration of infrastructure and deployment of code in a very similar manner to how they manage their software development process. Infrastructure as code means that infrastructure changes are represented as code, and the source code for the infrastructure is stored in a version control system like Git. This enables repeatable deployments and prevents runtime issues caused by configuration drift or missing dependencies. With GitOps, development teams are empowered with self-service deployments instead of being dependent on an external operations team. And once the DevOps engineer can treat infrastructure as code, the logical next step is to perform code reviews on the infrastructure changes before deployment to make sure they are correct. In this case, the code being reviewed may primarily be Kubernetes YAML manifests or other declarative configuration files, not really traditional code written in a programming language. Now let's look at the operational benefits of GitOps. One of the more prominent paradigms to emerge from the DevOps movement is the model of declarative systems and configuration. Simply put, with declarative models, you describe what you want instead of how to get there. Observability is the ability to examine and describe a system's current running state and be alerted when unexpected conditions occur. With GitOps, you can easily compare the desired state of the system stored in Git with the actual running state. Since with GitOps, all changes are revision controlled, audibility, compliance, disaster recovery, and rollback are all made much easier. Sorry for the shameless plug, but please check out the GitOps and Kubernetes book if you'd like to learn more in depth about GitOps. Now let's talk about how a GitOps operator such as Argo CD actually works. The GitOps reconciliation loop begins by cloning the repository to fetch the config repo's latest version. Next, the manifest discovery stage looks for any Kubernetes manifests to apply to the cluster. This is where a tool like Kustomize or Helm is run to transform the directory layout in the deployment repo into rendered Kubernetes YAML manifests. This is also where you can run your own tool to render the YAML instead of Kustomize or Helm. and we'll see a little bit more about that later. Lastly, the kube control apply step performs the actual deployment by applying all the rendered or discovered manifests to the cluster. So apologize if you're already familiar with this, but Kubernetes operates using something called a controller pattern, where there's multiple controllers in the cluster that are really just running as pods inside the cluster. And these controllers are looking for creates, updates, or deletes on a particular type of resource. And a resource is defined by some metadata, a specification, and status. So the controller will look for updates on these resources and then attempt to reconcile that resource so that the configured state, the desired state, matches the actual state. And that might involve making some Kubernetes API calls or some other operations. And once that's done, then the status of the resource is updated. So this is the way a typical Kubernetes controller works. Now, however, there's nothing to stop a controller from making external API calls outside the cluster. So for example, we could have a controller that makes SDK calls to AWS or GCP. So this is really where we're talking about managing external cloud resources. This is the mechanism to do that within Kubernetes. There are several open source cloud resource controllers that can be used with GitOps and Argo CD. The AWS load balancer controller is fairly mature with a V2 version recently being released. It allows management of, well, you guessed it, load balancers, very aptly named. There's also Crossplane, which supports multiple cloud vendors and multiple types of resources. And then AWS controllers for Kubernetes, or ACK for short, which is a collection of controllers for various AWS managed services. This project is still fairly new and not many are claimed to be production ready, but there's a lot of momentum behind them. However, at the time we started this project, Crossplane and ACK didn't exist. So we did what any other self-respecting development team would do, and we wrote our own controller. So we came up with, but what we wanted to do is we wanted to manage CloudFormation stacks using a Kubernetes controller. So we wrote a custom controller called Cloud Resource Manager. This was a pretty straightforward controller in the sense that it just did one thing. It processed CRs that represented a CloudFormation stack and created those stacks on a target account. So here's what an example CR would look like for a cloud resource deployment. In this case, we're creating an S3 bucket. This first section in the spec, the assume role provider, this is used by the controller to manage the connection to the target account and assume the necessary role to actually create the CloudFormation stack. We'll talk a little bit more about that in the next slide. Then this next part, these are the parameters. These are the parameters, the region, the stack name, the template. These are all the normal things that you would need when calling the CloudFormation SDK. So these are things that are actually passed into the CloudFormation SDK. And then you can see the actual template itself. And this template is fairly simple, but you can imagine you can also have fairly complex templates as well. The controller doesn't really care how simple or complex the template is, as long as it's a valid CloudFormation template. However, there is some usability issues when you start getting very big templates. And also at Intuit, we very rarely have a custom template that's used only once. We typically make patterns of templates, patterns of CloudFormation templates, so that we can reuse them and version control them and kind of keep them in a central place. So we had another effort to address that aspect, which we'll also talk about in the next slide, which is to create a custom tool for Argo CD that lets us represent lets us basically reuse these templates and generate dynamically generate these CRs from a project specification directory. So now let's talk about how to deploy cloud resources with Argo CD. And again, in this case, we're going to be deploying a CloudFormation stack. So it all start with a user making some configuration change, making a PR, submitting that PR, merging that to the main branch of the deployment repo. And Argo CD is, you set up what Argo CD calls an application. You set up an application in Argo CD that's watching that particular repository and a particular subdirectory in that repository. And when it detects any changes, it will call some tool. Usually it's Kustomize or Helm, but in this case, we're calling a custom tool called Manny. And Ravi will mention a little bit more about Manny later, but this is really our custom tool that we've installed into Argo CD that lets us represent a custom project hierarchy in the deployment repo. And it kind of takes the place of Kustomize or Helm in this kind of workflow. But whether it's a custom tool or Kustomize or Helm, regardless of which tool you're using, the end result is a series of YAML files, a series of Kubernetes manifests that are then can be applied to the cluster using kubectl apply. And that's essentially what Argo does. Then when the kubectl apply is done, that's going to create one or more CRs based on those manifests that were discovered by the tool. And in this case, it's going to create a CloudFormation CR. That CloudFormation CR is going to be picked up by the Cloud Resource Manager. Inside the spec of that Cloud Resource Manager, it may contain information about what cross-account role to use to deploy this resource, in which case it will use that cross-account role to create the stack in the target account. When the stack is created, it's also passed a service role so that the CloudFormation service would use a specified service role that would then create the actual objects in the AWS account. And that service role can be targeted to the types of resources that you want to manage using GitOps. The cross-account role is a very targeted role, only having permission to manage CloudFormation stacks. So it's a very limited role. But then from there, you can create any type of AWS resource that can be represented in CloudFormation. But this is what I really want to talk about. We are announcing here at this conference the open source contribution of the Cloud Resource Manager under KeikoProj. This is a new Kubernetes controller developed and maintained by Intuit that manages the lifecycle of CloudFormation stacks. We're also looking for users and contributors who want to participate in this project. And the URL is here on the screen. I encourage you to go check it out. Ravi is going to give us a more in-depth view of the Cloud Resource Manager and give a full end-to-end demo of how you can use Argo CD to manage cloud resources in a GitOps manner. Ravi, take it away.
Thanks, Todd. So the Cloud Resource Manager is now open source under KeikoProj. Please try it out and let us know your feedback. It's a Kubernetes controller built with kubebuilding. The custom resource for this controller essentially embeds CloudFormation stack into it. So whenever the custom resource is run, it will look for the corresponding state of the stack in the AWS. And then the controller would determine based on that state whether to stop the reconciliation or re-queue for reconciliation of the custom resource. So we identified a bunch of states for CloudFormation stacks, and we grouped them into two buckets. One is intermittent states and the other one is terminal state. Whenever the stack lands into the intermittent state, the controller would update the status as in progress for the CR and it would requeue for reconcile. If the stack lands in one of the terminal states, it would update the status accordingly if it's a success or failure and stop the reconciliation. Let's look at a live demonstration for this. So the custom resource for this would look like this, where the kind is cloud resource deployment, and this is the API version. You can update the fields. It would embed all the CloudFormation information in this spec, and the template for the AWS CloudFormation is given here. It would pick up the parameters and other things that are passed in the parameters section of the CR spec. Now, we can see this view in Argo CD. So we configure the application by passing in the repo URL, the namespace in which we want to deploy these resources, and the path in which in this repo the custom resources are present. We see that the desired manifest is generated by looking into the content in the GitHub repo. Live manifest is empty because we haven't yet submitted this into the controller. One of the things that we have noticed is that having to put this CloudFormation template in every resource is because this is too verbose. It would be an overhead for the engineers to maintain this and review it and stuff like that, as it is too verbose. So what we have come up with is we thought of grouping all the common things into one particular block and move the common templates into S3 buckets and download them at the time of creating this CR. So what we have done is we put all the common configurations like account number, environment, region, and all these things into the config YAML. And the core content for the custom resources, like the template, the CloudFormation template, we have put it into S3 and we have declared that it's a type of S3. And then we have passed in the parameters that this template would use. With this, it looks like a Scepter kind of configuration management, right? But Scepter would ideally create the resource as well. What we wanted to have is, based on this information, it should merge all this data and generate the custom resources that the controller can accept. So we've created a custom CLI, and we have configured this custom CLI in the Argo CD. The way we can use this custom CLI in the Argo CD is, this content is same. All that we need to modify is the manifest section, where we update the name of the plugin that we want to use to be Manny, which is a CLI that we have done. So we update this plugin name to be Manny. That way, whenever the Argo CD repo server, which actually reads the data from the GitHub repo, we execute this CLI command and translate all the configuration files that we have here into custom resources that the controller can understand. Now, if we look into this desired manifest, this is similar to what we have seen for S3 bucket configuration in this earlier app, right? So essentially here, we haven't used any CLI configurator. It is directly using customize. Whereas in here, we have configured our own plugin CLI. And we translated all the configs that we have declared into here, which are much simpler to manage and review. And those are getting translated into custom resources that the controller can understand. So this is a flexibility that Argo CD gives. We should utilize it if our needs match to this one, right? So now we can go ahead and sync these resources and see if they're coming up in the actual cloud account or not. So we've synced those resources. Yeah, so they are in progress now. As you see, there is a progress bar that's spinning. And the cloud resource is in progress. And we can also look at the events. So it started creating the chain sets. So we should see the events, the stacks getting created now. So these are all the stacks that we are creating. S3 bucket, NACL, and the security group. So it looks like the security group is already completed. So as it landed in the terminal state, we would have seen this one landed in a healthy state. So this is landing in a successful termination state. So we see that this is in a healthy and there is a healthy heart symbol. We can look at all the events that this CloudFormation generates in the Argo CD events itself. We do not have to log in into the account and watch it always. I was just showing this so that we see that the resource is actually generated and we could see the security group actually getting created. So like this, we can create all the cloud resources that we are interested in. We don't have to limit ourselves to these three, but VPC endpoints, VPC peerings, transit gateways, any sort of AWS cloud resources that can be created with CloudFormation stacks, we could create with this controller. So this is the security aspect. Now, we have seen how we can configure the custom CLI in the Argo CD UI. Let's look at what needs to be done in order for us to be able to use this custom configurator in the Argo CD while deploying Argo CD into the Kubernetes cluster. So this is a representation of what we have seen in Argo CD UI. So this is where we need to make the changes. We need to look at the Argo CD repo server deployment object. So we download the content of Argo CD deployment from the open source, and we edit the section where there is this Argo CD repo server. What we need to do is we need to introduce an init container, and this init container should download the mani binary, and then we volume mount this binary into a specific location. We need to use this volume mount in the main container of the Argo CD repo server, such that this CLI is available in the Argo CD repo server pod to be used by the Argo CD when it reads the data from GitHub repo. This is one part of it. The other part that we need to configure is what action it should do whenever it reads the data from the GitHub repos, right? So we need to configure that in the config map of the Argo CD in the config management plugin section. So we need to declare that whenever the Argo CD repo server reads the files in the given path, it has to run this command, mani-build.command, on all the files that are present there in that path of that repo. Like by default, Argo CD supports customize. So it runs a customize build.command. Then it merges all the files that we have declared in the customization YAML, and then it generates a final output, right? So similarly, in here, it looks up all the files that we have configured there, and it generates the custom resources as we have seen earlier in the Argo CD UI view. Now, this is how we configure the custom configurator CLI tool. Now we have seen that the Argo CD is qualifying the status as in progress, and it is giving us a spinning wheel when the PRs are in progress state, and when it is in a successful state, it is showing a successful heart symbol, right? So in order to get that, we need to update the resource customizations in Argo CD, where we have to embed a Lua script into it, and we need to update here that if the custom resource object status is in progress, we need to say that the object status for the Argo CD should be progressing, and the message that we see there should be cloud resource in progress. Whereas if it is in a success state, we qualify that as a healthy state, and so on. All this goes into resource customizations in the config map of the Argo CD. So these two are the changes that we need to do in order for us, one, to install a custom CLI tool in the Argo CD. Two, in order for our custom controller, if we have some specific statuses that Argo CD should understand and show it in the UI, we need to configure using the resource.customizations. Now let's look at how this controller is working underneath in the AWS accounts, right? So first we will have to create an AWS source account, and we have to create a Kubernetes cluster. This can be a GitOps-based cluster or EKS cluster, whichever we choose to create. And we need to deploy this controller into that. And we need to create an IAM role. This IAM role will have to have permissions to assume a CloudFormation master role in a target account. There can be multiple target accounts, so we need to create this in every target account where we want to create the AWS Cloud Resources. And this will have permissions to create CloudFormation stacks and pass a CloudFormation service role into the stack. And this service role will have a power user access in the account so that it can create the change sets and execute the changes to create the resources in the AWS account. So this is how we create all the AWS Cloud resources. We have seen that we have used this Mani as a CLI tool. In order for this to download content from S3 buckets, we can configure a role called Mani S3 role so that it can go and fetch the data from S3 bucket wherever we have configured it and replace the template in our CR declaration with the actual CloudFormation stack content. Yeah, so that is all the inner workings of this controller. Now, after we have this in place, we have seen tremendous results. However, I'll walk you through the state where we were in before this, right? So when we initially started creating clusters with the GitOps-based approach, we were creating the clusters almost a single cluster used to take 2 weeks. Although the GitOps-based cluster creation as such for the core Kubernetes cluster creation, it was not taking much time, but creating all the AWS resources was taking time. And managing these AWS resources, like whenever we want to make changes to these resources across multiple clusters, it gets to be very difficult. And auditing and debugging of these clusters was a challenge as well, right? So whenever something that we update it, let's say we're using a script, we don't know whether that is landing up in a successful state or not. So we didn't have an easy way to audit who is making the change to them and control it and stuff like that. So whenever we try to upgrade clusters, we used to see the cluster upgrades used to fail because some of the resources were in bad state or they got deleted by mistake and stuff like that. So this was all a big problem for us in the earlier stages. When we decided to move from GitOps to EKS based clusters, we had a migration to move from GitOps to EKS based clusters, essentially to simplify the management of control plane. We introduced this GitOps-based management of AWS resources using this project called AWS GitOps. With that, we were able to create as many as 50 clusters per day. We are only limited by IP availability so that we don't consume all the capacity given to us. And all the EKS clusters that we plan to create, we were able to create all of them in 2 weeks. And we saved about 15,000 manual hours with this bulk cluster creation using AWS GitOps. Today, we are managing about 3,000 cloud resource custom resources across all the accounts and about 10,000 AWS cloud resources, which can be a VPC or a security group, NACLs, or private links and stuff like that. Across all the resources seamlessly. This is the impact that we had with this work that we did. Thank you. And we are hiring. If you're interested, please reach out to us. Thank you.